Chemistry Paper 1, Limiting Reactants. For this question, it would be ideal to have a calculator handy. Also, a good knowledge of the periodic table. Two key points to note. In a chemical reaction involving two reactants, it is common to use an excess of one of the reactants to ensure that all the other reactants is used. The reactant that is completely used up is called the limiting reactant because it limits the amount of products. Now, there can be analogies to thinking about reactants that maybe make it more accessible. I like to think of limiting reactants when thinking about food. Everybody knows I love a ham sandwich. To make a dry ham sandwich, you need 1 slice of ham, 2 slices of bread. Therefore, if you wanted 100 ham sandwiches, you would need 100 slices of ham and 200 slices of bread. However, what would happen if I only had 80 slices of ham? If I only had 80 slices of ham, I could only make 80 ham sandwiches. I'd have excess bread. So that therefore means that the ham would be the limiting reactant. Here's a worked example. A mixture contains 1 kilogram of aluminium and 3 kilograms of iron oxide. For this question, it wants me to show the aluminium is the limiting reactant. The information has been provided, as we'll need to keep referring back to it. Step 1, work out the number of moles of each substance. You have been given the mass 4. Firstly, aluminium. Moles of aluminium equals mass divided by MR equals 1,000 grams divided by 27. This gives us 37 mole. Remember, in chemistry, to convert kilograms into grams. Iron oxide, again, same calculation, but this time 3,000 divided by 160 gives us 18.75 mole. You may be asking why 160? Refer to the information at the bottom. To calculate the MR of Fe2O3, 2 lots of 56 plus 3 lots of 16, and that gives us 160. Step 2, we then need to work out the mole ratio. Looking at the equation, we'll need 2 lots of aluminium to react with 1 lot of iron oxide. So we would need 18.75 mole of Fe2O3 to react with 2 times 18.7 mole of aluminium. 18.75 mole times 2 is 37.5 mole. We only have 37 mole of aluminium. Therefore, aluminium is our limiting reactant because 37 mole is less than 37.5. Have a look at the GCSE mark scheme. 1 mark given for calculating the MR of Fe2O3. 2 marks have been provided for calculating moles and then for identifying the limiting reactant. Here's a practice question. Same again for 4 marks. This time we're looking at 4.8 kilograms of magnesium reacting with 7.3 kilograms of hydrochloric acid. This time it's asking us to show that the hydrochloric acid is the limiting reactant. Pause and have a go. I will provide the steps on the next bit of the video. Again, we have the information at the bottom of the screen so that we can keep referring back to it. Step 1, we're looking at the number of moles. Remembering again that mass is going to be in grams. So there's magnesium, there's hydrochloric acid. Remember, hydrochloric acid is HCl, so that's 1H plus 1Cl. So that's 1 plus 35.5, and that's why I've got the 36.5 in this case. Step 2, mole ratio. We'll need 1 mole of magnesium to 2 moles of hydrochloric acid. So 200 mole of magnesium would need 2 times 200 mole of hydrochloric acid to fully react. (200 mole times 2 equals 400 mole. This is in excess. We only have 200 mole of HCl. HCl is the limiting reactant, as 200 mole is less than 400 mole. Let's check that against the GCSE mark scheme. How did you do? Were you able to answer all points? Again, 1 mark for calculating MR, 2 marks given for calculating moles, and then for identifying the limiting reactant.